Hello, everyone, and thank you for attending today's webinar, Maximize Profitability for Large-Scale Ground Mount Projects with SolarEdge TerraMax 1500V Solution. I'm Kelsey Misbrenner, Managing Editor of Solar Power World. Before we get started, I want to go over a few things. You can download the slides and any additional resources in the resource window at the bottom of your screen. We will have a Q&A at the end of the webinar, so please submit any questions in the Q&A window. If we don't get to your question, our presenters may reach out to you afterwards. You can also expand your view of the slides by using the icon in the top right corner of the slide widget. All the boxes on your screen can be moved and resized to meet your preferences. And finally, if you're watching this on demand, you can still use all these features, including sending questions to the presenters. If you experience any issues during this webinar, try refreshing your browser tab. If you continue to have problems, try closing other apps and browser tabs you have open. You can click Help in the top menu for more troubleshooting steps, or you can ask our producer for help via the Ask Question widget. So let's get started with today's webinar. I'd like to thank SolarEdge for sponsoring this presentation. Today, we'll hear from Amir Cohen, GM of Utility Scale and Community Solar, and Tim Stalker, Principal Product Manager for CC&I at SolarEdge. Now I'll pass things over to SolarEdge to get started.
Thank you very much, and good afternoon, everyone. Good morning for some of us. The focus for today is going to be SolarEdge's 1500V solution, and specifically, how do we address challenges and profitability on ground mount projects, be it community solar or small utility. First thing first, so SolarEdge, for anyone who doesn't know, we have been around for 20 years. Specifically in North America, we began our business here about 15 years ago. To date, we have over 500,000 commercial sites that are in operation. We work with more than 50% of the Fortune 100 companies in the United States. And we are the #1 player in rooftop community solar. So the majority of rooftop solar today in the US is being installed with SolarEdge products. We're also the market leader in residential solar, based on the latest numbers that have been released by different analysts and media outlets. So point being is that everything that you will see here is been around, is proven, and is not new. We have about 150 million optimizers that we've deployed. We've deployed about 7 million solar inverters to date and continue to grow. So again, there's nothing new from our end in this presentation, but really happy to share with you a little bit more. So today, really, the challenges that we are seeing in community solar are continuing to grow, and they go beyond the ITC and the changes to policy that are shaping in North America. And more specifically, when we look at community solar, small ground mount utility, some of the challenges are really around finding good, suitable land and land that's unconstrained. And these sites are starting to become less harder to find. They're less common. Specifically, if I'm thinking about the Northeast, the Mid-Atlantic, places where there's congestion in the grid, and we're trying to help alleviate some of that. These sites typically have angulating terrain. Grading these sites might be very costly, and as a whole, they're far between when we try to find them. Some of the other stuff is the challenges that we're dealing with. It could be the module degradation, the performance of the system, the soiling. I mean, some sites have shading on them, and we need to make some tough decisions. Are we going to expand the offset? And where we thought we might be installing a 5 megawatt, now maybe we're down to 4 megawatt. In some places, we're being asked by the local utilities or the local communities to have larger offsets than we might have expected initially when we looked at the project. So making these projects pencil is definitely becoming harder, and we're up against many more challenges. Skilled labor and workforce are also becoming more costly with prevailing wages and shortages of skilled labor. So what can we do to help alleviate some of these, right? These are some of the things that we're going to talk about in the next hour or so. Of course, FIOC is becoming more of a topic, and how do you get around FIOC? And again, for us, we do have a path forward. You're building sites for 20 or 30 years. You're doing performance modeling for the long term using different modeling tools. How do you ensure that you're getting accurate energy yield predictions? That, you know, at the end of the day, we're in the business of growing revenue, profitability. Can we rely on the tools that are out there to accurately forecast the performance of my site for the next 20, 25, 30 years? And last is my O&M and data analysis. How do I know if my site is meeting expectations? How can I troubleshoot my site and in real time figure out what's going on with my site, not to wait until an annual maintenance or semi-annual maintenance, and only then to get out there and to try to troubleshoot and so forth. Am I able to troubleshoot from remote and to run diagnostics from my computer, from the NOC, and kind of know before I go out to the site what's going on, both on the AC side and on the DC side? So these are some of the challenges that we've identified as really matters that are slowing down the adoption of community solar. And if we're able to help alleviate some of these concerns and challenges, we will help, hopefully, with faster adoption of community solar in these complicated landscapes. This is what we're going to talk about. So, Tim, let me turn it over to you.
Yeah, no, thanks, Amir. So today we're going to be talking about the TerraMax 1500V solution, and Amir just went through the challenges that we see in this industry in terms of adoption rates and the challenges that developers and EPCs are facing. So first, I'm going to go through the TerraMax 1500V solution. I'll go through the inverter, the optimizer, talk about the benefits, and then where, you know, what are the main differences between our solution and other ones that are out there. And then we'll go through a lot more details on use cases, and you know, we'll continue on with that discussion. But first, I want to talk about the 1500V solution with TerraMax. So that's it's comprised of the inverters, which is our inverter here on the left, the power optimizer, which is shown just next to the inverter, which again we'll talk about in the next slide. And then what really sets us apart, besides the technology that we bring to the market, the main thing that sets us apart is our monitoring platform through SolarEdge One. So this allows you to look at your entire fleets. It allows you to really fine tune and get down into the nitty-gritty details of every site and see what's going on. It's something that no other provider can really give you all the information. You can get down into the module level optimizer data, which can tell you temperature of the optimizer. It can tell you the production, the real-time data, all things that are really critical to really understanding everything that goes into operating and maintaining these community solar and large-scale solar plants. So first, let's talk about the inverter. You know, the one that we focus on for community solar and large scale is our 600V output inverter, which is 250 kilowatts and 285 kilowatts. So we have two different power classes. We also have a 690 as well. That's really better suited for larger scale plants. 600V market is really fine-tuned based on the supply chain around AC disconnects, around circuit breakers, around transformers. You know, 600V is kind of that sweet spot for a lot of the other, you know, AC balance of system side. But so we have two power classes of the 200 and 285. And that's, the power is good all the way up to 45C or 113 degrees Fahrenheit, which is very high temperature. So we do not derate like you see in a lot of other string inverters, and especially central inverters, which typically start derating after 25 or 35C, depending on the manufacturer. What's also really critical, I'll talk about in the next slide, is even the 250 has an apparent power rating of 285 kVA, also up to 45C. And so this allows for you know, some really neat operations in terms of being able to maintain a power factor, a relatively low power factor, without compromising on the active power that's being produced. And then you can do up to 200% DC oversizing with our inverters. So really allow you to capture more energy in the shoulder hours, and then clip during the day, but ultimately producing more energy when you normally wouldn't otherwise. And then it's designed for a max system voltage of 1500 volts DC. The optimizers, together with the inverter, are generating a nominal voltage of 1250 volts, which allows for kind of that buffer. And it's really the optimal voltage for generating 600 and 690 volts. If you tend to operate at a higher voltage, you're going to see more switching losses, you're going to see more inefficiencies, and ultimately those will impact the long-term production of the site. And then because we've taken the MPPT out of the inverter and into the optimizer, which is SolarEdge's main architecture of doing module level maximum power point tracking out in the field with our optimizers, the inverter is a very simple design, which allows us to get a very high efficiency of greater than 99% CEC efficiency. And then with a peak efficiency of 99.2, 99.3%. And then we maintain a high degree rating with an IP66. And it's a standard 5-year warranty that's extendable up to 10 years. And then, complementary to the inverter is our H series power optimizer. And this has a 25-year warranty from the bat. We have 2 flavors. We have a 1300 watt version and a 1500 watt version, which is coming beginning of next year. 1300 watt is available now. They both have a maximum open circuit voltage of 125 volts. So that means you string 2 modules in series for 1 optimizer. So it's a 2-to-1 optimizer. The 1300 has a max input short circuit rating of 15 amps, while the 1500 watt version, which is coming out next year, has a 20 amp. And then they allow for a very wide amount of modules to be connected to 1 string. So that's really one of the key benefits that SolarEdge brings when we pair this optimizer with our inverters, is we allow for string stretching and having mismatch of strings, and really being able to offer a lot of flexibility when it comes to designing a solar plant from the beginning. A lot of times we see people trying to design plants after the fact using what you would normally string a string inverter to. But when you use our H series power optimizers with the TerraMax, it really allows you to expand your frame and allow you to design for the site rather than designing to your inverter that you chose. So it provides a lot of flexibility. And then each string can provide a max power input in that string to 33 and 40 kilowatts respectively, and then a maximum continuous power of 25 to 30 kilowatts also respectively. And so this allows you to have fewer strings overall, which means less combiners, less fuses inside those combiner boxes, less switching devices, which ultimately saves a significant amount of money on the POS. And so Amir will talk about that when we go through a case study here in future slides. So let's start going through the benefits. So I already talked about the 0.88 power factor, and this may seem like, okay, what's the big deal? But the big deal is there's a lot of utilities that are requiring 0.8, 0.95 power factor rating for the inverters that are on site. And when you do a 0.95 or a 0.9 or even a 0.88, as you could go with our inverters, you're limiting the amount of active power that inverter can produce. Typically, an inverter is rated for, let's say, 250 kilowatts or 250 kVA of apparent power. When I operate at a 0.95 power factor, I'm now derating my active power in order to produce reactive power in conjunction with my active power. And so when I do that, I'm limiting my active power. And active power is ultimately what you're getting paid for. That's how you're making your money on your dollars or cents per kilowatt hour produced. And so if I'm derating that, I'm losing money. I'm leaving money on the table. So our 250 kilowatt device, it's limited to 250 kilowatts of active power, but it has a 285 kVA apparent power rating, which allows you to take advantage of that operating at a lower power factor without compromising on active power. Next one is we have a integrated PID nighttime rectifier. So PID is potential induced degradation. And this happens with pretty much all silicon-based modules that are on the market today. And this effect happens when you have a transformerless, ungrounded DC array. So a lot of, previous generations of central inverters were grounded systems. And so they are able to get around the PID effect on the modules. But now that we've gone to, the market has shifted more towards ungrounded floating PV arrays. And when you do that, you have to now take into effect PID. And so the inverter has a built-in nighttime rectifier that introduces a negative voltage bias on the DC bus, which basically counteracts the effects of PID. A lot of times, a lot of other string inverters, this requires an external box to be placed on that DC bus. And so if you have a string inverter, especially if you have multiple input string inverter, you now have to put this device on every single input because it will affect that pretty much every string that's out there. And so because we have long strings, we have a single input DC bus into our inverter. You only need that one inverter to have that PID nighttime rectifier. And so that's built in and included with our inverters. The next benefit is we offer the ability to pre-commission from the sun. So we do not require AC interconnection in order to power on the inverter. Our optimizers, when they are first turning on, or when they are not talking and they're not signaling to the inverter to turn on, they output 1 volt per optimizer. And so if you have 40 optimizers, or if you have 30 optimizers out in the array, you're going to get 30 volts in that example. And that 30 volts is enough for us to power our comms board and to be able to turn on the communication board and allow you, the customer, to pre-commission your inverter without requiring AC. So you can set your grid code, you can go and search for the optimizers that are out in the array, and you can set all the stuff up that would normally, like for a typical string inverter, you would have to wait until you get AC grid power in order to do that, or you have to have both DC and AC. And so we have the ability to either power from the DC side or power from the AC side. So it gives you a lot of flexibility, and this saves time, right? You can, a lot of times, projects that we are working on, they're waiting on interconnection, they're waiting for that grid connection, and they can't do anything until they get that grid connection. And then once they get that permission to operate, it's now a scramble to get ready and get the inverters commissioned. And so if you can get that done beforehand, it saves a lot of time up front. Our inverters have a leader follower topology. So if you have lots of inverters, especially if you use what we call our virtual central, which Amir will touch on later, where you have inverters on a rack design, they're all next to each other, co-located, connected to one transformer. You would have one set up as the leader and then the rest as followers. And so you only have to commission the leader when you set it up like this, and then the leader will go and search for the followers behind it, and then you're only commissioning one device. So it, again, saves a significant amount of time, a lot of confusion when you're doing this on site before you get PTO. And then with our optimizers, similar to our rooftop inverters and residential inverters and optimizers, we do have safe DC. So it allows us to reduce the voltage on that DC string when the inverter is either off, or if there's an event that's triggered, it allows the voltage to drop to a safe level that's safe to operate under 80 volts. And so that's natively built into our optimizers. Next one is AC and DC terminal block temperature sensing. So we have temperature sensors that are built in to all of our terminations on the DC and AC side. So basically all the high current terminations where there could be the potential for either a cable fault, either a lug didn't get crimped or properly. And so you don't have the copper touching the lug properly. And so it's heating up because there's that resistance that's built in. Or you could have the lug wasn't torqued properly onto the termination itself, which is, again, causing resistance to build up, and then that generates heat. And if you didn't have the ability to sense this, that's how fires happen. That's what happens when inverters fail. It's because of the inverter not able to properly detect when something like this happens. And so the inverter, if it detects it, it will shut off, and it'll notify through our monitoring portal the O&M service techs to go and check and make sure that the connections are made properly. And then I talked about the power factor previously with the first point, but the inverters are able to operate 0.2 to 0.2. So that actually gives a lot of flexibility in the reactive power support that the inverters can provide. which then actually goes into the ability to do what's called like queue at night or reactive power support at night. We can provide reactive power support to the grid at night when you normally wouldn't otherwise be able to. And so the inverters have that ability built in. And then the last one, because of our string stretching capabilities that I talked about before, the ability to optimize tracker table lengths, which can vary depending on manufacturer. You know, they typically have some type of linear actuator that's determining the tilt on the tracker rows and tables. And those linear actuators can generally, you know, there's limits on how much torque they can provide to be able to turn the tables the direction depending on where the sun location is. And the maximum length of those tables doesn't usually always line up perfectly with what a string inverter, how you would typically string a string inverter to, which is normally about 26, 27 modules in a string for a 1500 volt string inverter design. That doesn't always land perfectly. And so either you have to give up, you have to lose out on that additional table length, or the compromise is I have to do cross row stringing, which is very expensive, very time consuming because you have to trench and bury your cables typically. So that's you know, one of the main benefits together with trackers. You know, it is important to note that all of these, right, this is all about the solution, right? So it's the TerraMax inverter together with our power optimizers. They go together, they're required. It's not like you can buy the inverter by itself and operate it without it. It's designed to work together. And those optimizers are what's providing the benefit of long-term energy production increase, which we'll talk about here in a future slide. So just something important to note. So let's really quickly touch on the differences between a traditional string inverter that's using, you know, either multiple inputs, multiple MPPTs right at the inverter level, or it's a single input inverter versus the SolarEdge TerraMax solution. So with a traditional string inverter, the weakest module that's in that string is typically going to define the performance. It's not necessarily going to reduce all the way down to whatever the worst performing module is, but that worst performing module is going to affect the maximum power point tracking of that whole string. And when you have a module that's impacting that whole string, it's going to cause the other modules to, they're still going to produce power, but they're not going to be producing as much as they could if all the modules were exactly the same, seeing the exact same sun hitting, the irradiance hitting that module. It's never going to be the same. And so because the MPP tracking is happening at the string level, you're kind of getting a global average across all of those modules. And so you're not able to fine tune for, you know, every module, the needs that you see for each one. And there are differences I'll talk about here in a future slide, but, you know, what affects the modules and how are they different? And, you know, we talk a lot about shading, but shading is actually, especially for community solar and utility scale, shading's not a big issue, as much as of an issue as it is on commercial solar rooftops and residential rooftops. Community solar, it's more about aging, degradation, et cetera, which I'll talk about here in a future slide. But, you know, when you have strings, either multiple string input inverters or a single input inverter, you don't have that module level optimization. And then you also don't really have string level optimization. You do when you have a multi-input MPPT string inverter with all the MC4 connectors coming out of the bottom of the inverter. You do get some information of, okay, what's the, obviously I know the DC bus voltage, but I can also measure the current, but usually you're doing 2 strings to 1. And so you're averaging across those 2 strings, also not providing a whole lot of string level optimization. You also can't mix strings and modules within strings, and even together if you have multiple strings going into one input, all of those modules have to be the same. And this is a big thing that Amir will touch on later, where we're talking about mixing of modules for domestic content modules with non-domestic in order to meet that requirement. Having the optimizer provides a huge benefit that you can have mixed modules within a string and within the inverter itself. So it provides you a lot of flexibility on that point. And then with SolarEdge, because we have our H series power optimizers, again, connected 2 to 1, so 2 modules in series connected to 1 power optimizer, we're doing local MPPT out at the module level to them, those 2 modules connected in series, rather than on the string level. And so that provides that string stretching feature that I talked extensively about previously, but it also provides the ability to do local MPPT for those 2 modules. And, you know, depending on the amount of undulation you have in the land, which is that nice gentle slope, you know, slope lands that a lot of times we see in the Northeast and the Pacific Northwest, you know, that slope will cause a change in azimuth and in direction, which will natively impact your maximum power point tracking, you know, where you are in that IV curve of those modules. And so providing that on the module level, that 2 to 1 module level, really provides the most energy throughput that you can get. And then because we have our inverters and our monitoring portal that I talked extensively about previously, we have the ability to look at the optimizer level, which is those 2 modules. We can see exactly what's going on, and you can see the effects of either, you know, any type of degradation or soiling that may be occurring, or if you have a you know, a bypass diode failure, you know, all of that information can be seen in the monitoring portal through the optimizer together with the inverter. And then, as I mentioned before, we have the ability to mix modules within a string. As long as the modules in the 2 to 1 per optimizer are the same, they can be different from all the other modules that are in the string connected to other optimizers. So it really gives you maximum flexibility to provide that qualified facility per the ITC until it lasts. So now we're going to get into how we increase revenue with our added energy production, right? I've touched on kind of the basics of how we do that, but now we're going to get into a little bit more detail. So with the energy harvest optimization, right, you have SolarEdge, which you can see our optimizers are connected to modules, and then, but with a string inverter, they're connected in series, right? All the way for 1 home run connection back. So the string inverter might be 26 modules long, 27 modules long, versus the SolarEdge, which could be anywhere up to 80 modules long, depending on the module type, right? Higher power modules, you don't want that many in the string, just because you're limited on the output current. But you could have up to 30 optimizers, 60 modules in a string, which provides basically twice as long of a string, which means less home run connections, less everything else, less number 10 wire. And you can very easily see the effects that brings. So now let's look at this. Cloud is not to necessarily represent a cloud. What this really is meant to represent is some type of degradation, whether that's soiling, that could be tree coverage, especially on community solar sites. You know, when you develop a plot of land, when you install those solar, there might not be shading on the edges or on other people's land that's surrounding this site. But in year 5, trees grow, right? And now all of a sudden you have shading on the eastern edge of your array or the western edge, and now it's impacting your energy production in the shoulder hours. And so just because you don't have shading now doesn't mean you won't have shading later. And so that shading can be in the form of either manufacturing intolerance, either thermal mismatch, right? As these modules are ever so slightly pointed in different directions, depending on, again, the slope of the land and the undulating terrain, those will have thermal mismatches. And so obviously temperature of the module impacts the power performance of each module. You can have different tilt and azimuth, again, due to the challenging terrain that these might be installed on, as well as bifacial modules, right? The albedo of the land behind it, right? The reflectivity of the land, whether it's snow, grass, could be flowers, those will impact the bifacial gains. And so those also need to be taken into account. And then module degradation, they all degrade differently, soiling and shading, all important things will obviously affect how much energy is harvested. So if you can unlock more of that energy, you can unlock more profit. So going to hand it off to Amir, who's going to go through case study and talk about more of this in detail and how it impacts projects.
All right, thanks, Tim. So I know there's a lot of questions. I'm going to try to go through it so that we can get to some of the questions. But you know, the main purpose for today is to help show everyone how we make projects pencil better. And I think that can be true whether you're developing, whether you're engineering and EPCing projects. And really the technology is flexible. But the goal for all of us is to win more projects. And the goal for all of us is to, you know, generate more kilowatt hours. If I have a piece of land, and in this example, I'm taking a square box in the middle of an open field. So you know, it's not very common that we find these sites in community solar, but you know, nonetheless, this is the example. How can I maximize the return on my investment, right? If we think of LCOE, levelized cost of energy, and this is really what we're trying to showcase today, that in any project, it doesn't matter the size, the location, the utility, we will always generate a better return than our competitors. And that is true whether they are using string inverters, whether they're using central inverters. You know, cost up front is important, and we'll get into that, especially if I'm doing the engineering or EPCing the project. But at the same time, you know, if I can show a greater return, more kilowatt hour production for the same piece of land, that will help my overall economics and help me win more projects. So I'm going to touch on both these topics in the next few slides. The first one is just energy production, and typically in the US we use PV-Syst for energy modeling, and in this example we simply are taking this plot of land and design that was provided to us by our developer partner, and this is a 499 megawatt AC, 7.5 megawatt DC project, so 150% DC to AC, and we throw it into PV-Syst. Now, I want to make a point that we are not tweaking PV-Syst. Okay, we are not modifying anything. The way you do your modeling, that's what we want you to keep doing. But what we know about systems, what we know about modules and so forth, is that there's a lot of inefficiencies in modules. And furthermore, what you're going to see is when we take a SolarEdge inverter solution system, and we compare that TerraMax system to a string inverter, we're going to generate almost 9 gigawatt hours of additional energy, which is worth over $1 million of added revenue or project valuation. I'm going to show you how we do that. So the first thing is when we put optimizers in the array, we allow each module to perform at maximum capacity, as Tim mentioned, and we eliminate many inefficiencies of PV modules. Okay, so manufacturing tolerance, shading potentially, soiling, thermal mismatch, aging. Maybe you have angulation, right? So you have a little bit of different tilt and different orientation. Bifaciality, we like using bifacial modules. Why do we pay more for them? Because they produce more energy. Same with trackers. Why do we like trackers? You know, fixed tilt versus trackers. Well, we pay more on capex because we know it's going to generate more kilowatt hours, megawatt hours, gigawatt hours, and so forth. So when we throw SolarEdge into PV-Syst or any modeling software and we compare to traditional string inverters, okay, we will produce more energy. And typically we'll start at a few percentages at year one. And over time, because of module mismatch, because of module degradation, manufacturing tolerance, this is before soiling and shading. This is just the module behavior, the binning of the modules, the way modules are being manufactured. If you look at that curve on your data sheet, you're going to see that over time they degrade. And that means a big difference between SolarEdge and our competitors, the traditional string inverters. And in this example, this clean field square box project, that's 9 gigawatt hours of added energy for SolarEdge. That's over $1 million of added energy. That's the first thing that we bring to any project. So on any project, we will generate more energy. On any project, we will generate gigawatts of added energy, which results in millions of dollars of added revenue. And we're happy to sit down and go through PV system analysis and do comparisons to whatever you're using today to show you that value, those benefits. The second thing that I would like to highlight is the upfront cost, and it starts with balance of systems. And as Tim mentioned earlier, when we use our technology, we can have very long strings. We can have strings of 60 panels, 70, 80 in a single string, as opposed to some of our competitors, maybe 24, 25, 26 modules in a string. So what does that mean? Well, that means that if I'm able to go to much longer strings, I'm able to get some cost out of the design, right? If I'm now putting on my designer hat, my engineering hat, my EPC hat, well, if I'm able to get hundreds of thousands of feet of 10 gauge of PV wire out of the design, if I'm able to cut my number of combiner boxes by half, or maybe even 2/3, because I don't have strings of 25 modules. I have strings of 60 or 70 modules. That means that I have a third or a half of the amount of the DC combiners in my array, less fusing, less everything. That is capex. That is straight up cost that I can design out. And I'll show you what that looks like in a second. So these are some of the benefits. So if I look at this site, this is that square box that we looked at, and I'm putting all my inverters in a centralized location, which we 100% believe is the right way to do it, much better than distributing in the array. Now, the reason you might be distributing inverters in the array is because you're trying to get, better performance. You're using maybe a multi-MPPT inverter, but you're sacrificing cost because you have long AC home runs. Well, we give you the best optimization while keeping all your inverters in a centralized location, like in this topology. So we save you on your home runs. We make long DC home runs instead of long AC home runs. We give you the best performance at the lowest price. So what would that look like? Well, let's look at this. This is a helioscope example. And what you're going to see is when we compare our technology to a traditional string inverter, we go to 50 modules on a string instead of 25 modules on a string. We're going to be able to get about 20 miles of DC wire designed out. We're going to get half the amount of combiners designed out. So with 50% fewer home runs, fewer AC runs and combiners, we're going to be able to save 2, 3, 4 cents kind of all day long on your balance of system. And that goes a long way. And we are assuming that it's going to cost you more money to hang the optimizers. Yes, this is a system. It's the SolarEdge inverter with our optimizers. And you do need to hang them. And believe me, everyone knows how to do it because, again, if you're not to do it on the rooftop, and the majority of people are using SolarEdge and rooftop, then you should be comfortable to do it at the ground. And when I assume 90 bucks an hour and 2 people hanging 25 optimizers an hour, we're still saving you 2, 3, 4 cents on any project because of the long strings that I mentioned before. The other thing that has been beneficial to a lot of our partners is this virtual central solution, this pre-engineered, pre-wired skidded solution that we can pre-assemble and pre-wire in the warehouse and drop onto the job site, right? With the rack-mounted panel breaker, the switchboard, right? So everything is built into this rack. Now, the nice thing is if you're doing community solar and you're trying to stay under that 499 megawatt AC requirement, 2 of these will take you to 499. So a lot of time, our competitors, if they have a building block of 250, let's say, maybe you're at 4.75. You're sacrificing a few percentage points. And everything matters in our designs these days. So we can get you to 499 by deploying 2 of these skids, and that's what we did on this project. So on this project, and again, we can show you more savings on the skid, and just in the sake of time, I'm just going to go through the side by side. So SolarEdge system roughly is priced at, call it 5 cents a watt DC. Now again, I'm using 4 cents a watt for our competitors. However, there have been many price increases these days in the industry. And I have to say that some of the pricing that we're seeing today, and I just have it up here on another screen, is actually higher. We're seeing string inverters come in at even 5.5 to 6, 7 cents a watt, and maybe we're even better upfront when we compare to some of them. Now, yes, some are definitely in that 4 cents a watt range, but guess what? We have that eBOS savings that I mentioned. So if we can save 2, 3, 4 cents a watt on eBOS, and we know we can, we're happy to sit down and look at your pipeline and look at your projects. We're going to show you better upfront capex pricing. That is something that we have seen. That includes our inverters and our optimizers and our monitoring, which I'll talk about briefly in a second. Okay, that's before the added energy. With the added energy, even if we bring that to today's dollars, we net present value that, we are going to be, just a better overall solution. So the point is, just to wrap on this one, is we should not be more expensive on day one with the hanging of the optimizers, with everything that's involved in getting SolarEdge installed in the field. We're happy to spend time with you to go through your project pipeline, and we're going to give you significant value or project value in the added energy harvest that we would bring to the table that nobody else is doing. Last, and just to wrap, is we do provide you with module level monitoring that is real-time, continuous, and granular as part of our pricing. So we don't charge you for this. You can tie into it through APIs or Modbus control. So we have all of that available. As I mentioned before, we have 500,000 systems deployed roughly in the US. So we're very familiar with that. The other thing is we give you great visibility into what's happening on the DC side. So today you have visibility really to the inverter. Is my inverter down? Is my traditional string inverter down, or is it not down? Do you really know if your DC combiners are online, if they're offline? What's happening with your modules? Are they degrading faster than warranty? Are they out? Or bypass diodes are growing in your array? Tim mentioned PID before. So full granularity to what's happening on the DC side, not just the AC side, which is really where the majority of issues take place in our world. And last is, we SolarEdge have an advantage power protection program. Basically, we do deploy optimizers with our system, and if these optimizers do fail, okay, we provide you with a power protection guarantee. We will make you whole for lost production, okay? Because we believe in our products and we stand behind our products. So that is something that we're happy to again, engage with and talk about. So for the first 2 to 2.5 years, we will make you whole on lost production that results from power optimizers downtime. And again, we can do a whole session on this, and happy to take it offline. I definitely want to leave some time for questions. So we're happy to engage with anyone. We're happy to review your pipelines, happy to look at PVSys and Helioscope, happy to talk about safe harboring. Obviously, we are non-FIOC, so we make our products either in the United States or in Israel. And please reach out to us, schedule a session with us, send us an email, send us a note, and we can help you really grow your pipeline. And if you're already familiar with SolarEdge and you're working on projects, we'd love to support you with whatever is needed. So I think we're going to pause here and we'll get to some questions. So thank you very much.
Okay. Yeah, and you can continue to submit any questions you may have in that Q&A window. All right, so our first question here, what limits the TerraMax plus DC optimizer solution for utility scale projects, or what is the max megawatt limit that it should be used with?
Yeah, it's a great question. So, personally for me, I don't think there's a limit. It's a question of LCOE and the appetite. So we have projects that range all the way to 75 megawatt, 120 megawatt. And again, it's a question of what we are up against. I would say there's a portion of the utility scale world that is deploying string inverters, and there it makes, for me, it's a no-brainer. Once we start to go against central inverters, I mean, they are priced very, very competitively, and then we need to sit down and look at the project, scope and the added energy and the value that we bring to the table. So I would say up to the 20 megawatt is part of the question. For me, it's a no-brainer. Once we get about 20 megawatts, we have been awarded larger projects, but we really need to sit down and look at the economics.
Great, thank you. The next question, in a 5 megawatt system, how often is safe DC or temp shutdown happening?
Yeah, so we don't necessarily see these happen. I would say that obviously if you have a crimping issue on your DC bus, we're going to see temperature increase, and at some point when that temperature reaches 100 Celsius or above, we're going to annunciate and shut down that inverter and let you know, you need to get out there and check it out. But it doesn't happen frequently. I think that at the end of the day, it's about workmanship and getting the DC side installation done right.
Correct, and I might just add a little bit to that. If you have O&M professionals out, if they're working on the array or working on the inverter, right? Even for any inverter, you would normally shut down, lockout, tag out the system, and so that would be a scenario where you turn off. There's a DC disconnect in the inverter. Turn that off. You lock it out. It's got lockout, tag out capabilities, and then that the whole DC array is safe after that. So it's really a peace of mind, as well as just maintaining safety of the whole system.
Great, thank you. Next question, how well does TerraMax pair with First Solar?
Yeah, it's a good question. So we don't pair with First Solar. When we started out here about 15 years ago, we used to have optimizers that supported call it very high voltage. We don't do that today. But again, if there's a valid opportunity to reconsider, I'm happy to have that discussion. But in reality, I would say that right now, it's not something that we're planning on.
Okay, thank you. Next question, I might have missed it, but what's the approximate cost of the Advantage program?
Great. So the Advantage program does not cost more. The Advantage program really came out where we realized that there might be some pressure to roll a truck if an optimizer is down. And we're talking about, on a large project, you can count them on one or two hands. But we're talking about generating $1 million of added energy. That's why you decided to use our products. At the same time, rolling a truck to save 50 cents a day doesn't necessarily make sense for us. So what we want to do is we want you to roll trucks when you roll trucks. We want you to get, if it's once a year, so be it. Get there at the end of the year when you're doing your annual or semi-annual maintenance, and we'll pay you those few $100s for that downtime, for the lost production. It doesn't always make sense to roll a truck, which might cost you $500 to save 50 cents. So Advantage doesn't cost more money. We still have a 25-year warranty on the optimizers. We still pay you for, truck roll reimbursement. We give you a replacement RMA, and we make you whole for the lost production. So that's where that came from. It's a good question.
Great, thank you. The next question, what is the anticipated cost from the distributor?
Yeah, so the pricing that we shared is really the market pricing. We, again, reach out to your distributor and get pricing. And if you need help, please reach out to us and we'll make introductions and we'll support you. But this is where we're priced to the market.
Great, thank you. Which tracker brands do these inverters work best with?
Tim, you want to take this one?
Sure. Really, it's any of them, right? Any of the modules. So like Nextracker, ATI, FTC, Game Changer. right? They all have their own unique type of slew drive or linear actuator, which is driving the tables, right, on the trackers. And so it's not necessarily, well, we work with this brand. It really is applicable to any of the brands. And so it's not necessarily, can't say one or the other, is really all of them. But we do, especially ones that have somewhat odd numbers, like one of them has 120 modules. Obviously, it depends on the module size in the format of that module. But that's where 25, 26 modules per string doesn't evenly divide into that. And so you're leaving off some of that tracker table. And so being able to fully utilize it is one of the main benefits that I touched on previously.
Great, thank you. Next question, does the skid accommodate other equipment like transformers?
So for the virtual central, it depends. There's a couple different options, right? Not everyone wants a transformer on a single skid. Typically, the transformer is obviously the heaviest part, so it makes sense to actually have that shipped separate. It also is typically the longest lead item in this balance system for the whole site, and so it makes sense to have the transformer shipped separate and connect separately from the skidded solution. So you drop it on site, you drop the skid on site, the inverter rack, and then you connect in your immediate voltage transformer through a throw connection, a bus connection, and then it really is quite a small amount of labor, assuming everything else is connected. So typically, I'd say majority of the time the transformer is separate from the actual inverter skid.
Great, thank you. What is the availability of the 1500, the new version next year?
Yes, so I just want to make, if whoever asked that can elaborate, but this product has been out now for a couple of years. There is no new version. We have, today we talked about
the 1500 watt optimizer.
Yep. So we have, so just to get to it, right? What do we have?
Oh, yeah.
Today we talked about a 600 volt, 1500, 600 volt AC, 250, 285. On the utility scale, for the person that asked, we also have a 690. And I would say, as we go to the larger utility scale project, I'd be skidding 690 volt inverters, and here you're getting up to 330. These products are out, they're shipping, they're being installed. On the optimizer side, we have a 13 watt optimizer, which is the H1300. We have an H1500, which is coming out next year, which is a 1500 watt. But it's really not a wattage question, just to make sure that it's clear. It's more about the input current, right? The short circuit current of the modules that you're using. So that product is becoming available beginning of the year. And anyone who's worked with us knows that we also, depending on the project, can give waivers and work around as the manufacturer. So if you do have, and we are looking at projects now that are going in that needed the higher wattage optimizer, let's say, we have ways of solving that. So let us know which modules you're working with, timeline of the project. But we have a solution for any module out there other than First Solar high wattage modules, I would say, today. So we're not waiting for anything new to come out.
Great, thank you. Along similar lines, this person asks, can your optimizers work with higher power modules, like greater than 700 watts?
Yeah, absolutely. So our optimizers can work with the call it G11, G12 bifacials. The question is really on the spec sheet. If you go to our website, it's going to be on the input current. That's going to be the limiting factor. And Tim, I believe, can you clarify where we're at on that?
On what the input current is, or?
Yeah, so we're going to be at 20 ampere on your maximum short circuit current.
Yeah, right, correct, for the H1500. Yep.
Yep.
And for the H1300, it's 15 amps, but we have waivers to go higher if needed.
All right, great, thank you.
Uh,
The next question.
maybe,
Oh, go ahead.
Go ahead. No, please go ahead.
Okay. This person is asking, can you name a couple of distributors who you can purchase the TerraMax and the DC optimizer from?
Sure. So all of the SolarEdge distributors carry the product or have it on their price list, I would say. So I don't want to miss out anyone, but CD, BayWa, Soligent, Rexel, OneSource. Hopefully I'm not missing anyone, but really anyone that would carry SolarEdge has access to these products. I get somebody sent me another question, if it's okay, about the ability to mix. Can I mix different module wattage at the string level using TerraMax, such as a 540 and a 580? So the short answer is absolutely. And Tim mentioned before this qualified facility requirement from the new IRS 2025-08. So at the end of the day, and this is true for all SolarEdge inverters and optimizers, each optimizer really isolates that modules that it's working with, or two modules that are sitting behind it. So on a single strings, you can mix modules, and that's the thing with the domestic content requirements, depending on your tax advisors and the people that you're working with. So you need to check. You may be required to mix domestic content modules with non-domestic content modules to qualify for the 40% or 50% threshold. And that may be required at the inverter level, or some people are asking to see it at the string level. So if I need to mix modules at the string or the inverter level, and I don't want to impact my performance in a negative way, SolarEdge is a great alternative to whatever you're using today for you to be able to do that. So I'm happy that was asked, because this is going a little bit deeper, but very important nonetheless. So yes, you can mix modules as long as you're working within the parameters of the optimizers.
All right, great. Let's see, there's one more question. Let's answer that. Someone's asking about the projected savings, and they're wondering, why does it grow from 2.5% in year 1 to 5% in year 20? Can you explain that?
Sure. Tim, do you want to take this one? You want me to?
Yeah, I mean, I think it was the slide that you presented on, Amir, where it's showing the PV system energy production from year 1 to year 20, right? And so as you go in year 1, right, the modules, right, when you're comparing SolarEdge to a traditional string inverter, the modules are at their highest performance, right? They haven't degraded at all, and typically because of binning, right, they're lumping common cells together, right, in the factory, and that's how you get your different power classes within a module frame. But those modules, as they degrade over time, they degrade differently, and so you're going to see differing performances, not only from cell to cell within a module, but also module to module. And so that the number is relatively small in the beginning. Again, it depends on a lot of factors, like the size of the system, the undulation and angulating of the terrain, and depending on how severe that is, that can also have a significant impact on energy production. But that number grows just because the difference between the highest performing cell and the lowest performing cell is getting wider. And so we're able to capture what would otherwise be lost due to the averaging of the maximum power point tracking algorithm in a string inverter. And so that's why it continually gets bigger over time. Now, obviously, we're producing less and less energy year over year because modules degrade, right? That's happening across the board, but they're degrading at different levels. And so that's what we're compensating for, and that's how we're able to get additional energy in year 20 than you would otherwise.
Maybe just to add one thing real quick. So regardless of whether you're using SolarEdge or any technology, module age, they degrade, you have a manufacturing tolerance, maybe thermal mismatch, right? So there's a lot of inefficiencies that would present, and these grow over time. When you use a string inverter, a non-SolarEdge, what we call a traditional string inverter, it's the Christmas light analogy, right? They're all connected in series. So if I have one module or a few modules that are underperforming, my entire string is going to underperform. That's going to bring the performance of everything down to that common denominator. In our case, these modules are still degrading. They're still aging. They're still suffering from thermal mismatch or what have you, but we're isolating those with the optimizer so they don't impact the entire string, and there is no common denominator. Each one or each two in this example is behaving independently and degrading independently of the others in that string.
All right, great. Those are all the questions that we have time for today. If we didn't get to your question, we will reach out to you directly. Please take a moment to fill out the survey that will pop up when this webinar concludes. We will use your feedback to improve our future webinar programming. This webinar will be shared with all registrants, so you can view it again whenever you'd like. I'd like to thank our speakers for being here and SolarEdge for sponsoring today's webinar. And thank you to everyone for joining us today. We hope to see you for more Solar Power World webinars in the future. Thanks, everyone.
Thank you. Bye.
Thank you.